Welcome! In this video, we're going to discuss depth perception. By the end of this video, you should be able to describe how monocular and binocular cues are used in the perception of depth and distance perception. For depth and distance perception, in other words, to see how far away or how close an object is, our brain can use information from both eyes or just one eye. Binocular cues require both eyes working together, while monocular cues are used for objects that are farther away, over 50 feet away, and it does not require both eyes working together. So just to give you a little feeling on what binocular cues are and how they use both eyes together, the first binocular cue we're going to talk about is convergence. So convergence is the turning inward of our eyes, which occurs when we focus on a nearby object, like this cross-eyed cat here. So the idea is when our eyes turn inward, the musculature that is changing in our eyes sends signals to the brain to tell us how close or how far away an object is. So let's try this. Put a finger out in front of you, about an arm's length, just one finger, and stare at it. Bring it closer and closer and closer. You feel your eyes converging or crossing? And do you feel a little strain in your eyes as it gets closer, almost all the way to your nose? That change in musculature is sending signals to your brain to tell you how close or how far away that finger is. Another one is retinal or binocular disparity. So this is the slight difference in lateral separation between two objects as seen by the right and the left eye. To get an idea for what this one is, put two fingers out in front of you. Now move one closer. Close one eye, close the other eye, one eye, the other eye. Do your fingers appear to be dancing a little bit? The idea is that your brain is using information about where those images are hitting the back of your retina to tell the brain which one is closer and which one is farther away. As we said, monocular cues use only one eye, and for objects over 50 feet away, we can't really rely on retinal disparity or convergence. So this picture, which is my daughter Carrie when she was about 1.5 and my husband and I in the background, is a good example of linear perspective, which is where parallel lines converge in the distance, and the greater the convergence, the farther the distance is. This pathway here being, we assume, would be parallel lines. Also light and shadow. There's shadows back here, it's light in the front, gives us 3 dimensions. Relative size, she's bigger, we're smaller. The assumption is that she's closer. Relative clarity, again, she's very clear. We're fuzzy here in the background. Same with texture gradients, much more texture here, not so much back here. This is a good one for interposition. So the objects that block one another must be closer. So here are these helium balloons. This one is in front of the other one. It's blocking the other one, so our brain perceives it as being in front of the other one. These two are blocking this one. There's interposition. Therefore, these must be closer than this third balloon. And again, you can see relative clarity, texture gradients at play here. Here's a really good one for texture gradients and relative clarity. As you see here, obviously it's much clearer here in the front. As we get back, the haziness of the beach suggests that this is much farther away than these trees here in the front. And here's, of course, a great one for linear perspective with parallel lines of the train tracks, parallel lines of the buildings, parallel lines of the rocky pathway here surrounding the train tracks, all converging in the distance, suggesting that this is closer to us than this is back here. And just coming back to this visual illusion, this one has the idea of relative size. So if you look over here, it looks like he's obviously much smaller, or farther away because he's much smaller than she is. We also have, remember, this idea of parallel lines where we would assume that this room is square, but in reality it's a trapezoid. And so it isn't flat here, it actually is sloping down. And I'll leave you with this meme, just in case you need a little help. Same image. Here it looks, you see the eye of the rabbit, the ears of the rabbit, or the bills of the duck and the eye of the duck.